Hello everyone, welcome to part 2 of the CYPE 3D series, Modeling and Design of Portal Frame Shed. If you remember in the part 1, so we created this model using the portal frame generator, and so we came up to this level. And definitely, as we said, so we can use the portal frame generator just to create the let's say the cross section of the portal frame in a faster way, and also we can generate the let's say wind load automatically using this integration or workflow between portal frame generator and CYPE 3D. So later I will show you how the let's say loading are applied, or let's say to this structure, and I'm not going actually to apply any wind load to this structure, but also I want to show you the way that you can create the model from CYPE 3D from scratch. Okay, so if I go to open CYPE 3D, okay, so I'm going to open a new file. Okay, so here I will just, actually I'm not going to use this model, just to show you how you can create this model from scratch, and then so we will continue on the existing model that we imported from portal frame generator. So here just I choose some dummy name, and then accept, and here also I'm not going to change the let's say parameters like code or steel grade or concrete grade, because the purpose of this presentation is to show you how you can create the geometry of this portal frame shed that we created in portal frame generator and imported to CYPE 3D. So I want to show you this procedure only. Okay, so here is the the main interface of CYPE 3D, and if you remember, we said that according to the let's say query that we had from our follower. So here I have something like this. Okay, and then here I have the 6 meter, and up to, let's say here, which is up to here, is 7.5 meter, and from here to here is 18 meter. And also the model that I imported from file portal frame generator, so I have a beam here, and then a beam here, and something like that. Okay, so then I will go to create this model, and I will take a copy by just to generate 15 spans. So then after that, so I will continue from the existing model that I created using portal frame generator. Okay, so let me do it. So first of all, I will go to bar. Okay, and then here I have the new option. So definitely from here, if you want to specify a specific section, so you can go to the bar option. So you can click on this. Okay, and from here you can select any section that you want. For example, here I can change it to UB section, and from here so you can select, or you can go to UC section. Okay, and then select the let's say universal columns, and with any let's say dimension. But again, here the purpose is not this. Okay, so the purpose is to show you how you can create this portal frame using CYPE 3D from scratch. So I will just select one of this UC, and again from here, as I said, you can go from different series of sections that you have, and then so simply you can click on or let's say select the proper section, and here also you have different sections, but for now so we are going to select the hot ruled I-beam section, and then accept. So the software again asks me if I want to check the fire resistance. So, but for now, I don't want to check this option, but if you want to check, so here simply you can check, and here you have the information for the, let's say, required resistance against the fire, and here you have the R30, for example, for 30 minutes or 60 minutes or 90 minutes, and then here you can also specify the protection coating. Okay, again, under different, let's say, conditions, so you can select a proper value or parameter. So I'm not going actually to select any option from here, which means I'm not going to check the fire resistance and then accept. Okay, so once you have this, so right now we select the UC 254 by 73, and I will start from here. So here is the intersection of this reference lines. Okay, and if you look at here, so here I have the global coordinate system, and it is like that. So here I have Y, I have X, and here the vertical one is Z. So which means exactly here I have the X-axis. So here I have the Y-axis, and this one is exactly Z-axis. So that's why we are going actually in this manner and using the reference line to create the let's say the structure. So you see here I just come here, okay, and then start. So when you start this, make sure that you are exactly parallel to Z axis, and doesn't matter how much you are going far from the intersection of this reference line, because later the software asks you how much is the length of this column, for example. You see here right now I'm going by 12.2 meter, but I'm not caring about this. Just simply click, and then the software here asks you, okay, so how much is the length? So we said that here we have 6 meter, so I put 6 and then click enter. Okay, so right now I have the let's say this 6 meter. As long as you have this, so another reference line, let's say corresponding to this node, will be created or generated. Okay, so in Y direction and also in X direction, and then so you can use this reference line, okay, to complete your model. For example, in this direction, if you remember here, we said that we have 18, and that's why simply I can go to this way. Again, doesn't matter. For example, here I'm going 4.4 meter. Just I need to click here and just write 18 and then press enter. Okay, and then I can come down. Again, here you have the reference line corresponding to this node, and here I have the vertical reference line as well. So I will click here, okay, and then right click. So now I have this. So here I need to let's say create the apex here, and I will go to the node, okay, create the new node, and from here, so just again here I have the measuring option. So doesn't matter how much I'm going, so I know that the span of this is 18 meters and I need to go for 9 meter exactly. So that's why, so I will click somewhere exactly on the beam here and write 9 and then enter. Okay, so here I have the node, and now I can go to node again, and here I have the move option, so I can move it. As you can see here, I have the reference line, which is actually parallel to z-axis, the vertical one. Okay, again, doesn't matter how much I'm going far from this, or let's say the origin of the node. So I will click somewhere here and say that 1.5. Okay, so we said that the apex is 1.5, which means the total height is 7.5. So and then enter. Okay, so I have it. So now we create this. So here we have this, and then also we need to create let's say the inner member or trusses. So let me go back to, let me also remove all of them. So let me remove all of them, and from here I want to check from here just exactly what I have. So here it seems at the middle of this rafter I have one node, and at the middle here also I have another node. Okay, but if you want to, let's say, see the distance or dimension, so you can go to planes, and here I have the dimension, and from here I can go to show dimension and general dimension. So here I will go to here. As you can see, from here to here is 4.5 meter. Okay, so here I have 4.5 meter, and then so all of them let's say just specify as 4.5 meter. So I will go back to here. Okay, and then again, so I will go to create a node. First I will go to bar, new, and I will create this, let's say, beam. It makes easier for me, so I will create this beam here and then right click. So now I can go to the node, new, So I will make sure that I'm attaching to this horizontal beam. Click here and then write 4.5 meter, enter. Okay, and also from this side, because the reference node right now is this point. Okay, so I will come from here and then write somewhere here and then 4.5, enter. So now here I have 4.5, 4.5, 4.5, 4.5. Okay, so now I need to connect this, because as we said that previously, so as soon as you create the node, so the reference or corresponding reference line will be created. So that's why here I have the intersection between this rafter and this reference line. So simply I can add one node here, or directly I can go to the bar and then go to new again, because here I have the intersection. So I will start from here, okay, just like this. Okay, and then I will come to here again. I will go back to here, okay, and then come down and then right click. So now I have this, let's say, geometry. If I go to tools and then if I go to render view, you see here it is the thing that I have. So if I want to just make sure that everything is correct, so I need to go back to here. So I have this one, and here I have also this vertical let's say member. So I will add this vertical member here. Let me go to bar, new, and also here I will create this vertical member. Okay, so now I created this, and I need to copy it by, let's say, 15 times. So for copy this, so you have two options. First of all, I will go to tools. So it is the simple option. So simply you can go to tools and then copy elements. So from here, I will select the nodes and bars, accept. So I will select all the, let's say, members, and always at the bottom side, which means here, you have the instruction for the command that you selected. Okay, so right now I selected the elements, and here also it says that select a group of elements. So already I select them, and then so you need to do right click. So just right click, and as you can see here, the command just changed, and here it says that, sorry, it says that insert the first point, so which means the reference point. Okay, so I will select the or insert the reference point here. So I can, since I have the reference line, I can select this point or this point or here this point, doesn't matter, because I can actually exactly go across the, or let's say exactly parallel to the this reference line. Okay, and then I can put as 5 meter. So for easy process, so I will select this node here, this node, and then so I will come to here. If you remember in this model that we imported from portal frame generator, so I have actually 5 meters. So that's why here also I will go for 5 meter. Again, doesn't matter how much I'm let's say moving in this direction. Okay, so just it is the matter of keying the value. For example, here 5 meter and then enter. So I have actually this one. And here one interesting thing happened. So previously the reference line just actually were continuously in this direction, in let's say x direction. So because we didn't have actually any border. Let me go back to show you once again. If I go back, you see here in this direction I don't have any border. So that's why, so you have all the let's say reference lines, okay, continuously, and let's say infinite reference line. But in this direction I have actually the cut, which means already the software understands the border of this geometry in the y direction is from here to here, and also in the z direction. So here I have this reference line, and also here it is the border. Okay, so that's why it's just limited from here to here, but in this direction I don't have. As soon as I added the copy, for example here, if I add the copy here, okay, so again all this reference line will be removed, because again in the x direction the software understands that here it is the border of this let's say structure or model. Okay, so it is very good things. So let me just once again go to copy. Again, select all the members. If you look at the instruction at the bottom side, so you will see that it says that select a group of element. I selected the group of elements and then right click, okay, and then select the reference point and come in this direction, okay, and write 5 and then enter. Okay, so you see here the reference line that previously we had in the X direction, all of them are just cut, because here the software understands the geometry and border or boundary condition of the model. Okay, so it is the way that you can use the copy option or simple copy option. And the more advanced option here we have under generation. So you can go to planes. Okay, and from here again, if you look at the instruction that you have here, select the two orthogonal reference lines that will define the plane on which you wish to carry out the generation. So generation, which means copy. So here the software simply tells us that you need to select a plane, and since we want to copy the member in this direction, which is actually in the X direction, so that's why we need to select a plane which is perpendicular to this direction, which is this plane. So for selecting this plane, so I need to select maybe this reference line and this reference line. Okay, and then so the software automatically understand that we are working on this plane which is perpendicular to the X direction, and the copies will be generated in this direction. Okay, so let's do that. So I will select this line, as you can see. Okay, it is the first line, and the second line I can select this or this or this or this, doesn't matter. Just you need to select one vertical line to tell the software it is the plane that I'm working with. Okay, so I will select this let's say vertical reference line, and here I have the number of generation. Okay, I have the number of planes to be generated, so which means the copies. So here already I have actually now 1, so I need another 14. Okay, so I will say 14, and separation between planes, so which means here between frames, so I can say that 5 meter. Okay, and then so here later we will actually group the members. I want to show you how you can group the members, but here just for sake of creating a model exactly like actually whatever we imported from Portal Frame Generator. So I'm following that model to show you how you can simply create the model in CYPE3D from scratch. So that's why here I will put number of planes to generate, which means the copy is 14. Already I created one copy, and separation between planes 5 meter, and then accept. Okay, so now I have it. Okay, so I have this model, and the only difference between this model and the model that we imported from let's say Portal Frame Generator is the applying the wind load. Okay, so in the model that we imported from Portal Frame Generator, already I have the wind load assigned, but here I need to assign the wind load manually. So here in this model, if I go to the load, okay, or let's say first I can go to the project, general data, and if I go to additional load cases, you see here I have no primary load defined. Okay, I need to assign especially for wind. Okay, so we are talking especially about the wind. Here no wind load is generated. You need to do it manually, and then so you need to go to let's say load option, and then here you have the introduce panel. Okay, but let me also go back to the model that we imported from Portal Frame Generator. If I go to the load, okay, you see here I have actually some panel already created, because the options already have been activated. For example, edit load on panels. If I go here, you see here the panel automatically has been generated. And if I go again to load, and here also if I go to the introduce surface load, here again I have actually some information for surface load, because here again the parameters or options for surface load has been activated. For example, here I can go to edit surface load cases or edit surface load. If I go to edit surface load, you see here I have actually the loads, and here also you can see that a number of wind load automatically been generated. Okay, so here I have all this let's say generated load, so I didn't define any wind load manually. So that's why it is actually the usefulness of using portal frame generator to create the wind load automatically. But if I come to this model, go to load, you see here for panel, so I need to create it by myself. Nothing is let's say created yet. And also for surface, again, I have nothing. And another thing that I need to let you know, here we have the surface load. Okay, so if you remember, once we were creating the model in portal frame generator, so we said that we want to have the lateral wall. Okay, so if you remember, we had something like this, and we were talking about the lateral wall. Why? Because actually, it was requested that the let's say the this portal frame structure is a closed surface. Okay, so that's why, again, you can refer to the first tutorial, part 1, and here actually we discussed about lateral wall. Okay, just to consider that our let's say portal frame is a closed, or let's say has the closed surface laterally. Okay, here and also here. Okay, so that's why here you can see the surface let's say surface load, because already in portal frame generator we assign the let's say lateral wall. Okay, so it is the reason. But here in the model that we created from scratch, so I have no information about the panel, okay, and also no information about the surface load. If I want to create it, so I need first go to the project and then general data. So from here I need to go to additional load cases. From here I need to create the, for example, first one, I need to create the live load. Okay, so here I will select the warehouse and then live load, accept. Okay, and here I need to create the dead load. If you remember, so for the model that we imported from portal frame generator, here I wrote roof load. Okay, accept. And another load case that I created was for solar panel load. Okay, so here also I can apply the solar panel load and then accept. So here I create actually this two, and then here I have two dead load, one live load, and also here I need to create the wind load, because here, as we said, once you are starting the model from scratch using CYPE 3D, so you need to introduce the wind load manually. So here I say wind and then accept. So here I have one wind load, and later I will use this primary let's say load type to assign the wind load in different direction, X or Y direction, negative, positive direction. Accept and then accept. Okay, so once you want to apply the wind load, so shortly I can tell you that you can go to the load, and here you have the introduce panel, so you can go to the panel. Just for sake of learning, so I can go to here, just assume that I have the wind load in the Y direction, which is from here. So I will create this panel by selecting this node, and then this node. You need to select actually 4 nodes, okay, and then come to this node. Once you come to the third node, you can again press or do right click. Okay, just right click, and then here the software asks you select the distribution direction for the surface load assigned to be to the panel. So I will accept it. Okay, so here just sorry, something is wrong. Maybe I selected the wrong nodes. Okay, so again I will go to introduce panel. So let me be more accurate. So I will come to here, select this node. Okay, and then so here I will come to select this node. Okay, and before, let's say closing the panel, so you can right click. Okay, so here you have this, and here you have actually the direction. So here it is actually in the X direction, and this one in the Y direction. Just assume that, for example, here it is the actually the distribution direction. If you want to load the columns, if you want to load these columns, so definitely you need to use this direction. And if you want to let's say load the this beam or and this beam, or maybe sometimes you have the gears. Okay, so here maybe you have the gears and then you want to load this gears, so then you need to select this direction or this line. Okay, so since here I don't have any gears, so that's why I will go to select this line and I want to load the columns. Okay, so I will just select this line. Okay, after selecting, again right click. Okay, so just do right click, and then here you have the option for adding the let's say wind load. I can go to add load, and here I have the sorry, because I already click on undo, so I can go to project. Okay, and from here, so we said that here we have the roof load. Okay, and another one is the solar panel load. Accept, accept, and here I have the live load and it is the warehouse. Accept. From here also I will go to the live load. Accept. Okay, and here also we can say that manually we can add one bin load type. Okay, and then accept, accept. So right now I have this. Okay, so now I can go back to, let's say, load, and you see here I have actually the options that is activated right now for panels. So I will go to edit load on panels, select this panel. Okay, and then right click. From here you can add the bin load. Okay, so here you have all the loads. You have the roof load, you have the solar panel load, live load, and also wind load. So I will select the wind load. Okay, again here, since I'm applying the wind load, if you look at the global coordinate system, the y direction is in this direction, and we want also to apply the wind load in the y direction. That's why here you can see the let's say the direction of the load is 100% in y direction, because the value for x and z is 0. Okay, but later I will show you once I have the inclined surface. So again, the software automatically calculate the let's say the load pressure let's say in x, y, and z direction. So let me first assign the wind load in absolute y direction. Okay, so after selecting this, so simply I can here say that the value, for example, I can go 0.8 kilonewton per meter square. Okay, so here it is actually the value again, so you need to just calculate it by yourself. So I'm just showing you the way that how you can apply the wind load. And also you need to know that here this value has the direct relation with the wind speed. Okay, so in different codes we have different equations, and simply you can convert the wind speed to let's say wind pressure. Okay, so here I have the wind pressure as I just as a windward direction, so I put as 0.8. okay, and then accept. So I will accept to this one. Maybe I want to have another, let's say, a panel, but this time, so I want to go for this inclined, let's say, surface from here, here, here. Okay, and again you can just right click before closing. And again here I want to load the rafters, so that's why I will select this line and again right click. So again I will go to here, I select the wind load, and here now you can see that the load or the pressure can be let's say decomposed in y and z direction, because this one is not exactly in the x direction, because x direction is this direction, and definitely so we are not applying the wind load in this direction. So it is very clear. That's why the software automatically understands this, and it just apply the load in y and z direction, which is the component of this pressure. And here also I will say that 0.8, it is windward, let's say, and I will accept it. Okay, so now I have actually this load to these two panels. So once you want to see the let's say the composition of this pressure load to the member load. So you can go to the load. Here you have the visible load case, and here directly I can go to the wind load and then accept. Okay, so here you can see that the wind load is applied to these members. Okay, so here there is actually a very important point. As you can see here, the load direction, you see here it is actually in the positive y direction, but this one is applying in the negative, let's say z direction. Okay, so for changing this for this panel, so I can go back to load and then here edit load and panels. So I will select this panel and then right click. So here I will say minus 0.8. Okay, and then accept. So if I go back to the load, visible load case, wind load, and right now, so here it is applied exactly in this direction. Okay, but the beautiful of this decomposition is that so the pressure load automatically decompose to the member load. Okay, so you don't need to put much effort to apply the let's say member load or line load to the rafters. Okay, so it is the beauty of the software and using the panel load. Okay, so but if I go back to the model that I imported from Portal Frame Generator, as we said, so here I have the panel and also surface loads, and if I go to the edit on surface load, so here all the loads generated automatically. Okay, so if I want to show you, for example, the first wind load, and if you want to see it in a better way, so you can go to the load, and here you have the scales. Okay, so right now, since I want to see the first scenario of the wind load, so here I will make this one as 7, or some of them maybe scenario 2, 3, 4, okay, and 5. So some of them I just scale up the load and then accept. So now I can go to load once again, go to visible load case. I want to see only the first one, accept. Okay, and here you see you have the, let's say the load that applied already to this members. Okay, so guys, it is for second part of CYPE 3D series, and please stay tuned with us and subscribe to our YouTube channel to get the next series and also other useful tutorial, not only for CYPE 3D, so also for other structural software solutions. Thank you so much, and we will come back to you soon on the part 3. Have a great day and stay safe.